Now, in the sensitivity report, you should see two tables. So one for variable cells, the other for constraints. Now, I have put in a lot of comments in order to explain what is the reduced cost, allowable increase, allowable decrease for the variable cell table. For every of them, I have given some explanation. And for the constraint table, all the explanation is listed at the bottom of this spreadsheet. Okay, now let's look at the variable cells, reduced cost. Now here you will see some of the reduced cost does not equal to 0. For instance, number to buy for model 1, its reduced cost is 4. Then when you check the final value of number to buy for model 1, it is 0. So 0 is our boundary. Remember, our boundary constraint is all those variables, decision variables, need to be non-negative. So 0 is the boundary. Currently, number to buy for model 1 is 0, means buy nothing. Okay. Now, if we really want to buy something to get a positive final value, what we need to do? It's indicated by reduced cost. So more specifically, it means this coefficient of number to buy for model 1 actually is its cost. $61 has to be reduced more than $4. So you will, if it's reduced more than $4 from the $61, go down below $57 after reducing this $4, then you will start to see they're going to buy something for the model 1 instead of buy nothing in the current setting. Okay, now let's look at allowable increase and allowable decrease. Its explanation is exactly like the example we have seen before. The only thing I want to point out is, please notice, in here, you will see this 1e plus 30. What that means? That means an infinite large number. So if we take this first line as the explanation, so number to make for model 1, allowable decrease is an infinite large number. So what that means? That means no matter how you decrease the cost for making model 1, okay, no matter how you decrease, how much you decrease, you can decrease as cheap as possible, even go to the negative, okay, then value won't change. The optimal solution won't change. You will always make 3,000 for the model 1. Okay, so remember this 1e plus 30 just means infinite large number. Okay, now for the constraint tables, let's look at the shadow price. Now this time you see not only positive shadow price, you also see zero shadow price and negative shadow price. Now for zero, this is zero shadow price only happen when the constraint is not binding. So this consume D19. If we check our model setting, D19 actually is for wiring capacity. So how many wiring capacity consumed by the current optimal solution? 95/25. How many available? Is 10,000. So wiring capacity is not fully utilized. It's not binding. So shadow price is 0. It means you increase, you already have enough wiring capacity. You don't need to increase it anymore. All right. Now let's look at the negative shadow price. This is for harnessing. So harnessing have a negative shadow price. What does that mean? First, as long as it's not equal to 0, it means this resource must be binding. So then clearly, so it's also verified by the table. So it's a final value 5,000, and what would be actually available 5,000. So constraint right hand side also 5,000. So they are binding. Then -7, what that mean? That means if you increase harnessing capacity by 1 hour, your optimal solution value total cost will reduce by $7, okay? Because it's negative. Then for those positive things, then if you reduce 1 unit, then the cost will increase by the shadow price. Now again, in the shadow price, you will see for the allowable increase, there is 2 places you have seen. You can see the 1e plus 30. That is an infinite large number. So for instance, for this the shadow price of the wiring capacity. So this allowable increase is infinite large number. So that means no matter how big you are pushing up this wiring capacity, shadow price remains 0. And this actually is intuitive because you already have enough capacity. You push it even higher, it's still enough.